In the early 1950s, the de Havilland Comet launched commercial aviation into the jet age. It was a revolutionary moment in aviation history, marking the dawn of a new era where air travel would become faster, more efficient, and more accessible to the general public. The sleek design and powerful jet engines of the Comet promised a future where the world felt smaller and more connected. Passengers loved its speed and smooth flight, no more noisy propellers or long travel times. The Comet offered a level of comfort and convenience that was unprecedented. People could now travel across continents in a matter of hours, experiencing the thrill of jet travel for the first time. But soon, disaster struck. The initial euphoria was short-lived, as the aviation community faced a series of tragic events that would forever change the industry. Several Comet jets broke up in mid-air, resulting in tragic loss of life. These catastrophic failures were not just isolated incidents but a pattern that raised serious concerns about the safety of jet travel. The aviation world was stunned and desperate for answers about why this futuristic plane kept failing. The public's confidence in jet travel was shaken and the industry faced immense pressure to find a solution. Investigators eventually zeroed in on metal fatigue. This was a relatively new concept in the context of jet aviation, and understanding it was crucial to solving the mystery. Repeated pressurization at high altitude caused tiny cracks to form, especially around the Comet's square windows. These cracks were almost invisible at first but grew with each flight cycle. Over time, those cracks grew, and the fuselage catastrophically tore open. The structural integrity of the aircraft was compromised, leading to sudden and disastrous failures. This was a new phenomenon for commercial flight. The industry had never encountered such a problem on this scale, and it required a new approach to aircraft design and maintenance. Jets flew higher and faster than propeller planes, subjecting their airframes to intense stress on every journey. The higher altitudes and increased speeds meant that the materials used in construction were pushed to their limits. No one fully anticipated how these pressure cycles could wear down metal. The science of material fatigue was still in its infancy, and the Comet's failures highlighted the need for more rigorous testing and better materials. As the crashes kept coming, de Havilland grounded the fleet, halting all Comet flights to prevent further tragedies. This was a drastic but necessary step to ensure passenger safety. Engineers performed exhaustive tests, literally submerging fuselages in water tanks to detect where the cracks originated. These tests were painstaking and thorough, aiming to uncover every possible flaw. Their findings changed aircraft design forever. The lessons learned from the Comet's failures were incorporated into new design standards that prioritized safety and durability. Rounded windows, thicker skin materials, and reinforced structures became the new gold standard. These innovations significantly improved the safety and reliability of commercial jets. Although the Comet returned in later models, its reputation had been badly hit, and other manufacturers like Boeing learned crucial lessons from these tragedies. The aviation industry as a whole became more cautious and methodical in its approach to new technologies. Ultimately, the Comet disasters showed that pushing the boundaries of technology demands rigorous testing and continuous safety improvements. The sacrifices made during this period were not in vain, as they paved the way for safer skies. Modern jets owe a debt to this pioneering airliner, whose painful lessons shaped the way planes are built today. The legacy of the Comet is a testament to the importance of learning from past mistakes to build a better future. Thanks for watching. If you appreciate deep dives into engineering history, like this video and subscribe, because the YouTube algorithm doesn't always spotlight crucial aviation stories. Your support helps us bring more insightful content to you. Question: would you have flown on the first commercial jet, even with the risks we know now? Let us know in the comments. Your thoughts and experiences are valuable to us.